Hi. It's 11.4 coordinates, polar coordinates day 2. We are going to be converting rectangular to polar and polar to rectangular today. All right, so this lovely diagram here kind of shows you the representation or the the similarities. It's kind of like if we had taken a polar plane. Remember, a polar plane is, one that's just, it's circles, right? Concentric circles. Those are terrible. And if we basically put it on top of a coordinate plane. So you have, if we're heading to the right X and up Y, okay, so that would be like if we were graphing, there's my rectangular coordinate X, Y. Well, we have, if we're looking at this, we superimpose the polar plane on top of it, we have an angle that we have rotated through, and we have, a radius, or quite frankly, guys, it's a hypotenuse. It's kind of like we're combining, it's kind of like right triangle trig again. So what you're really going to need is, and basically all of this says the same thing, so take a look at this, but what you're really going to need is two things. If we're going from polar to rectangular, you're going to use x equals r cosine theta and y equals r sine theta. And I think I forgot to pause when I flipped the slide, so you might I might have said things that you didn't hear, sorry. So basically that's what you're going to need. All right, so let's do some practice. All right, so I know that this is polar because it's in radians, and I've got 3 pi over 2 right there. So honestly, honest to goodness, all you have to do is x equals, my radius is 2 times the cosine of 3 pi over 2. And guys, yes, you'll have the formulas available to you, but honestly, you have spent so much time on the unit circle, you know that when I ask you for the cosine of an angle, you give me the x coordinate. So that's really where it's coming from. So cosine of cosine of 3 pi over 2. So this is really going to be x equals 2 times cosine of 3 pi over 2 is 0. So that's 0. And then when I go to do the y coordinate, it's the same thing. Y equals the radius times, instead of cosine, it's the sine. But remember, that kind of makes sense because sine is y. So 2 times sine of 3 pi over 2. So really it's 2 times the sine of 3 pi over 2 is a -1. So it's -2. So your actual answer, okay, is, oopsies, sorry, didn't realize it was the highlighter. Your actual answer is 0, -2, okay? So if I were to take on a rectangular Cartesian coordinate plane and graph the point 0, -2, and I would superimpose a polar plane and have graphed 2, 3 pi over 2, they would be in the same spot. Assuming we had all our scales correct and everything like that. It had to be to scale, but that's really what it means, okay? So, next one. Our radius is -8 and our angle is pi over 3, so -8 times the cosine of pi over 3, right? And so that's really -8 times a 1/2. And so that x is going to be a -4. Whoops. Okay. And then when we go to do sine, it's going to be y equals -8 times the sine of pi over 3. So that's -8 times, that is actually a radical 3 over 2, right? If I went to pi over 3 and I grabbed the y coordinate. And so that's -4 radical 3. And so when I go to write them, it is -4, -4 radical 3. Okay, so again, this right here is my rectangular. This right here is the polar. Okay. Okay, we're going to try just 2 more real quick ones. Again, pretty straightforward. X equals, my radius is 3 times the cosine of pi, and that is 3 times a -1, which is -3. My y is a 3 times the sine of pi, and so that's going to be 3 times 0 or 0, and of course then that means my rectangular is -3, 0, right, when the polar was 3 pi. And then if we do the same thing for the next one, we've got x equals, the radius is -10 times the cosine of pi over 6, So negative 10 times radical 3 over 2 is negative 5 radical 3. And then our y value is going to be negative 10 times the sine of pi over 6. So that's going to be negative 10 times 1/2, which is negative 5. So negative 5 radical 3, negative 5. That is, again, the rectangular or Cartesian coordinate. And that negative 10 pi over 6 is the polar coordinate. Okay. Okay, so now we're going to go from rectangular to polar coordinates. Now, here's the deal. This little bit right here is actually pretty important. You always want your radius to be positive, and you want your angle to be in between 0 and 2 pi. Now, if you watched the video from yesterday or you looked at the notes from yesterday, you will remember that we can write many versions of the same point in polar coordinates. The radius can either be positive or negative, and the angle is, like if it was 45, we can add 360 or subtract 360 or, anything like that. You've got multiple representations. So we put that point where that little statement right there, those two inequalities right there, we put that there so that when you are solving for these, you know that you want your radius to be greater than 0 and you want your angle to be in between 0 and 2 pi. If I had changed anything from that set of inequalities, it would change my answer. But remember, that's just rewriting things another way. It's kind of like when we write 5 squared is 25, is 20 plus 5, is 50 divided by 2. There's just multiple representations of it. All right, so the important thing is to plot the point. Guys, it doesn't have to be perfect. It doesn't have to be anything intricate. The reason you want to plot the point is so that you know what quadrant you're working in. And that does come into play in step 3. Now, finding r is pretty straightforward, guys. You're just looking for the radius of the, well, not radius of the circle, I shouldn't say that. Well, yeah, kind of technically radius of the circle. But honestly, it's just the Pythagorean theorem, right? It's just r squared equals x squared plus y squared. So r equals the square root of x squared plus y squared. Okay, now, when you are doing this, there are multiple ways to do this, but honestly, the fastest and easiest and tried and true way is to do the inverse tangent using your calculator. So when we get to step 3, that's what we're going to do. All right, I want to convert negative 1 radical 3 to rectangular. And of course, I am going to go draw that real quick. Negative 1 radical 3 is going to be over here, okay? And that means I went left 1 and up radical 3. So I have to find r. R is very straightforward. Remember, it's just a right triangle, so r squared equals negative 1 squared plus radical 3 squared, right? So r squared is going to equal 1 plus 3. So r is actually going to equal 2, right? Because it's 1 plus 3 is 4, so r equals 2. So when we're trying to find this, we're trying to find an r and a theta. Well, I just found my r, so there's my r, so 2. Now, when you do this, you can do, we'll go to, oh, we like that pink. All right, so we're going to use tangent, okay? So we're going to sit here, right? We're going to sit, and there are ways to do this other than what I'm going to show you. The next example I'm going to do kind of touches on those, but this always works, okay? So when you're doing this, you're going to sit right here and you're going to do opposite, sorry, what am I doing? You're going to do opposite over adjacent, right? So tangent of theta equals opposite over adjacent, right? Now remember, when you are actually looking for the angle, you are doing inverse tangent, okay? Now, you go and you plug this into your calculator. Make sure your calculator is in degrees mode. That way then you know exactly what angle it gives you back. Your calculator is going to give you negative 60 degrees, okay? And that's okay. But the reason that we draw our picture is so that we realize where we're at. Negative 60 is down here. Negative 60 degrees is down in the 4th quadrant. Our angle has to be in the 2nd quadrant. So to get there, all we're going to do is add 180. Guys, if we want to be in the quadrant directly across from, we add 180. If we want to end up in the same quadrant, we would add 360, but we're not doing that. So this is technically 120 degrees, but you got to write it in radians. So when you do... Okay, so apparently the sound on the original video went out at this point. Thank you, Carter, for letting me know. So I'm just going to continue talking right now. I literally had to sit there and watch the entire thing, and hopefully this works. But anyway, it was 2 and 2 pi over 3. So we are going to convert -1/2, negative radical 3 over 2, rectangular coordinates to polar coordinates. And again, you want to draw your point, again, just so you know what quadrant you're in. And obviously you don't have to. It's just always nice to have that visual representation. And then remember, you've gone to the left 1/2 and you've gone down radical 3 over 2. And really you're looking for the radius. That radius is going to be the distance from the origin to the point itself. And it is honestly just the hypotenuse of that right triangle. So r squared equals -1/2 quantity squared plus negative radical 3 over 2 quantity squared. So r squared equals 1/4 plus 3/4. Gosh, I write slow. I must be rambling about a bunch of different stuff. So r squared equals 1. So r is going to equal 1. So our radius is going to be 1. And we have to go find our theta. So our theta, not our theta. We just found the r. So when we do that, of course, you are welcome to do inverse tangent of y over x. So it would be negative radical 3 over 2 divided by -1/2. That will equal your theta. And I say that it will equal some form of your theta. We'll get to that in a minute. I'm circling the two fractions right now because I'm talking about how we can look at the unit circle, and because those are actually coordinates that are on our unit circle, you go to your unit circle and find the angle that has the coordinates x is -1/2 and y equals negative radical 3 over 2. So you're in that quadrant, and the angle down there in that quadrant that has those coordinates is 4 pi over 3. Am I writing it? There we go. All right, 4 pi over 3. And then I'm pretty sure, there we go. Okay, I thought I did. If you went to your calculator and did inverse tangent, your calculator will tell you 60 degrees, and that's totally fine. But again, your calculator gives you an answer that might be close to what you need. You obviously have to interpret it. And because we don't want to be in the first quadrant, we want to be in the third quadrant, we're going to add our 180 degrees, which gives us our 240 or our 4 pi over 3. All right, so the last two, we're going to convert -2, 0 to polar. And it's really, guys, anytime you have a point that is on one of your axes, it is super awesome sauce easy, because what ends up happening is you graph that point, and really your radius, remember, is the distance from your origin to your point. So it's really just going to be the absolute value of the -2. So you've got 2 there, and then your angle, it's a quadrantal angle, so it's on the axis, so it's either going to be 0, pi over 2, pi, or 3 pi over 2. In this case, it's pi. You just have to look at what axis, what part of the axis it's on. You know, is it the x or the y-axis? And then are we, you know, to the right, or we to the left, or are we up, or are we down? So if you look at the last one where we're converting 0, -4, obviously I draw it just so I can see it. And again, your radius is your distance from origin to point, so that's going to be 4. And then it's going to be 3 pi over 2, because that's the angle that goes straight down.